8.2 notes, graphs of other trigonometric functions. This is page 10. So first things first, I do want to correct a couple of things that really I don't want in here. So down at the very bottom, we're going to work from the bottom up. We are not going to start by graphing the tangent function. Second thing is this mistake right here. So that too should not be there. So we are going to just knock that off, okay? If you are graphing based on what you know about the function, you should be fine. If you are comparing with the formulas, those were not going to match. And so I apologize. I will get better about that. Anyway, so example 9, let's take a look at how we're going to graph y equals 3 cotangent 4x. So we're going to pull some stuff out of this equation. You notice there is no phase shift here. Cotangent is not one of those ones that we graph a ton. The phase shift, the vertical shift will work exactly like when you graph tangent. Okay? So we're going to focus on just what the cotangent graph looks like. So we have a stretch factor of 3. We have a period of pi over b, absolute value of b. In this case, b is 4. So our period is pi over 4, and I'm going to go ahead and set this up so that it's big enough for me to see what's happening. One. Okay, we have no phase shift, and we have no vertical shift. And so right now we're going to go down to the next page, and I want to compare tangent and cotangent just a little bit. Okay? So with tangent, we know how to find the asymptotes of that standard function. So our asymptotes are at negative pi over 2 and x equals pi over 2. That's when the period is pi. No adjustments. Okay? And that happens when our sine of x over cosine of x is undefined. So let's take a look at cotangent and where those asymptotes are going to be. Because we do have places where the cotangent is undefined. Okay? And so we're going to come down here a minute. Cosine of x over sine of x. We need to figure out where that is undefined. Okay? And that happens when x is 0. Cosine is 1, sine is 0. That happens when x is pi. Cosine is negative 1, sine is 0, and then 2 pi. So that happens at the multiples of pi. So with no adjustments, the asymptotes are at x equals pi times k, where k is an integer. Notice that's at the ends of the period, the start and the finish, okay? So coming back up to our graph here of cotangent, because I have no phase shift, I have an asymptote at the beginning of my period, and I have an asymptote at the end of the period. And all of my asymptotes are going to be 1 period apart, so pi over 4 apart. Okay, we can double check with this formula above here. Asymptotes occur at x equals, make this an x equals. C over b, here c is 0, so that doesn't matter. Plus pi over 4 times k. So when k is 1, we have an asymptote at pi over 4. Or when k is 0, we have an asymptote at 0. Those work. When k is 2, we have an asymptote at 2 pi over 4, so pi over 2. Makes sense, okay? So I'm going to use the formulas to double check my asymptotes, not necessarily to find them. So we know that same as tangent, we're going to have a 0 halfway between the two asymptotes, right in the middle. Cotangent is 1 over tangent. So we are going to end up with cotangent going the opposite direction that tangent does. So rather than going up to the right like tangent, it's going to go down to the right. Okay, it's our cotangent graph. Here we've got a stretch factor of 3. So if I go over 1, if I split this half of the period, the bottom half and the top half, I'm going to go down 3 to the right. I'm going to go up 3 to the left because we are accounting for our stretch factor. I'm going to make that dot bigger because I missed it. And this is what our cotangent graph looks like. And that is it for these notes.